Have you ever wondered why, while the world remains embroiled in debates over fifth-generation fighters' stealth and super-maneuverability, China's J-20B suddenly earned the 5.5 generation designation, even prompting military analysts to rethink the future rules of aerial warfare. From the moment the J-20 took its maiden flight in 2011, it was destined to be anything but a status quo aircraft. Initially hailed as a game-changer in Asian air combat, few anticipated that the true revolution was only just beginning. Today, the upgraded variant known as the J-20B has not only made the leap from possession to mastery, but has achieved a generational breakthrough in technological evolution, all centered around a technology once confined to sixth-generation aircraft concepts: flexible skin. A fighter jet's skin is far more than the simple layer of metal or composite material visible on the surface. It is the physical carrier of aerodynamic performance and stealth capabilities, serving as the aircraft's primary interface with air and electromagnetic waves. While traditional skins appear smooth, they inevitably generate micro-separation at high speeds, and during high-maneuver flight, creating radar-detectable turbulence zones and signal-scattering sources. This is akin to a sprinter wearing slightly loose clothing. Wind resistance increases invisibly, and movement becomes impeded. The advent of flexible skins has fundamentally altered this scenario. It brings the aircraft's surface to life. Through embedded smart materials and micro-actuators, the skin dynamically adjusts its shape based on real-time flight conditions, maintaining optimal aerodynamic configurations while minimizing abrupt radar echo changes. This enables the J-20B to leap from static low detectability to dynamic adaptive stealth in stealth capabilities, while achieving near-ultimate optimization in aerodynamic efficiency. This is precisely what defines a 5.5 generation fighter. It doesn't enhance performance in a single aspect, but elevates the ceiling across multiple dimensions: stealth, maneuverability, sensing, and decision-making, through system-level integration. To illustrate, traditional stealth fighters resemble heavily armored warriors, excellent protection but somewhat cumbersome in movement. The J-20B, however, is like an assassin clad in intelligent liquid armor, capable of silent infiltration while executing agile turns and decisive strikes in close combat. This leap in capability isn't achieved through more powerful engines or heavier weapon loads. It stems from a dual upgrade in design philosophy and technological advancement. More significantly, this technology is not an isolated breakthrough. It shares the same technological lineage as China's sixth-generation fighter, the J-36, currently under development. A defining feature of sixth-generation aircraft is the intelligent airframe, integrating flexible skins, distributed sensing, AI decision-making, and directed energy weapons to achieve high adaptability between the platform and its environment. The J-20B's pioneering use of flexible skin signifies China's successful completion of the closed-loop process of preliminary technology research, engineering conversion, actual aircraft application. This reflects a rolling evolution approach that diverges significantly from the Western generational leap development path. In other words, rather than attempting to cram all future technologies into a single platform to achieve a sixth-generation aircraft in one leap, China focuses on enabling mature platforms to continuously absorb cutting-edge technologies through iterative upgrades, ensuring sustained technological leadership. This strategy delivers tangible deterrence. While the U.S. Air Force has proposed sixth-generation concepts, including variable-shape skins, under its next-generation air dominance initiative, it remains in the technology validation and prototype competition phase. China, however, has already achieved preliminary operational capability with similar technologies on its active-duty fighters. This means that while others' futures remain on blueprints and test grounds, we have already set foot in tomorrow. Beyond its flexible skin, another major breakthrough for the J-20B is the mature application of the domestically produced WS-15 engine. This high-thrust, low-bypass ratio engine, nicknamed MI, finally frees the J-20 from reliance on Russian-made engines, truly achieving a Chinese heart. The combination of more powerful and reliable propulsion, with aerodynamic enhancements from the flexible skin, has significantly improved its supersonic cruise endurance and maneuvering overload capacity. This enhanced thrust-to-weight ratio advantage translates directly into tactical superiority. Pilots can sustain supersonic flight for extended periods without engaging afterburners, not only conserving fuel and increasing range, but also granting the fighter greater energy dominance during engagement. positioning, and disengagement maneuvers, complemented by real-time micro-adjustments to its aerodynamic profile. The J-20B demonstrates exceptional maneuverability across the transonic range. This fundamentally addresses the degraded handling characteristics traditionally encountered by fifth-generation fighters at these speeds. Meanwhile, avionics advancements continue apace. Sensor fusion and tactical management systems powered by more sophisticated AI algorithms are being integrated, enabling the J-20B to approach the highly autonomous combat model envisioned for sixth-generation aircraft in complex electromagnetic environments, enhancing target identification, threat prioritization, and coordinated engagement capabilities. In essence, it has grown not only physically stronger and more agile, but also intellectually sharper and deadlier. Its onboard systems can simultaneously fuse massive sensor data streams, automatically generate tactical recommendations, and even manage wingman aircraft and drone swarms, functioning as a small aerial command node. This capability enhancement has exponentially increased the battlefield influence achievable by a single J-20B. From a strategic perspective, the Chinese aviation industry's development model of rapid incremental advancements and continuous capability enhancement significantly alleviates cost and risk pressures during equipment upgrades. It ensures both the rapid expansion of existing combat forces and the reliable development of combat effectiveness, while keeping the entire fleet in a virtuous cycle of dynamic upgrades and sustained technological leadership. Opponents no longer face a static generational gap target, but a continuously shifting technological frontier. This cycle of deploying one generation, developing the next, and researching the following is accelerating at an unprecedented pace. The validation of technologies like flexible skins on the J-20B will undoubtedly reduce engineering risks and shorten development cycles for subsequent sixth-generation fighter projects like the J-36. Notably, the practical significance of flexible skin technology extends far beyond individual aircraft performance. It signifies China's cluster breakthroughs in a series of cutting-edge fields including smart materials, microelectromechanical systems, and active control algorithms. These technologies are not confined to fighters but can be extended to bombers, UAVs, and even hypersonic vehicles, driving a performance leap across the entire aerospace equipment system. For instance, future unmanned wingmen employing similar technologies would see dramatically enhanced stealth and survivability, significantly boosting the combat effectiveness of manned-unmanned collaborative systems. The emergence of the J-20B thus transcends being merely an upgraded fighter variant. It signals China's aviation industry has evolved from a technology follower to a technology definer, and from an equipment producer to a shaper of battlefield rules. While others still debate the gap between fourth and fifth generation fighters, China has quietly ushered in the next competitive phase through the operational deployment of its 5.5 generation aircraft. The early implementation of technologies like flexible skins serves not only to enhance a single fighter model, but also to lay the groundwork, validate concepts, cultivate talent, and build an ecosystem for true sixth-generation fighters like the J-36. The future is here, though not yet evenly distributed. The significance of the J-20B lies in its ability to make us clearly see that future rapidly taking shape in the skies of the East. The Chinese Air Force is advancing steadily and resolutely toward the forefront of global air combat systems with a unique and efficient rhythm. This not only shifts the balance of power in Asia but also redefines the developmental paradigm of air power in the 21st century. As the flexible skin on the J-20B's fuselage ripples in the wind, it stirs the skies of the entire future battlefield.